Hello everybody. Today we are going to be discussing graphing exponential equations. Okay, we've taken all this time now and we've graphed lines. But now we're going to kind of switch gears and we're going to talk about something that you may or may not have heard of before called an exponential equation. Okay, so unlike a linear equation, exponentials are going to make graphs that do not make straight edges, straight lines. Okay, we're going to talk about what the graph is going to look like in a few moments. But first of all, let's just start from the beginning, start basic, and define what exactly this thing is. Okay, so as you see here, I made this little chart here. You can pause the video just to write this down. That way you can keep up with it. But here we go. An exponential equation is an equation of the form, okay, y equals a times b raised to the x power. Okay, and that makes sense because if it's an exponential, the word exponent is in that word. So the variable is going to be in the exponent spot. Okay, now there's a couple rules that come with this formula. And one is this a value cannot equal 0. That's one rule. Okay. Second of all, this b value has to be greater than 0. Okay, which means b has to be positive. Okay, and the other thing with it being positive, b cannot equal 1. Okay, that's the only thing. Because anytime you plug 1 in, 1 really is uninteresting. Okay, and we really want to get a good idea of what the graph is doing. So these three rules must be followed. A cannot equal 0, B has got to be greater than 0, and B cannot equal 1. Okay, and the exponent must be the variable. All right, so that's just a few ground rules. Notice how this is way different from y equals mx plus b, where, that made our linear equation. M was the slope, b was the y-intercept. Okay, well, things are going to be a little different now. So in further lessons from now, we're going to actually talk about the huge differences between a linear equation and an exponential equation. But please, halt on your curiosity. I know you all are very eager to learn all this. Just take it in through baby steps, okay? Promise? Good. All right. Now, the graph for what we're looking for is called and just for shortening, it's just a J-curve. Okay? And what I mean by that is that it's going to do a couple things. Your J-curve, we have two different types. You can have one where your curve is going to look like this. This is what the actual graph is going to look like. It's going to look like this and then go all the way up like that. And you can see it sort of resembles the letter J. Okay? Or on the opposite side of it, it can go the other way. We could say that it goes like this. Okay, so it sort of makes the backwards looking J. Okay? Now, we're going to define these two types of graphs. Now remember, we read from left to right. So from the furthermost left point, working our way up to the right, okay, do you see how this J curve here is going up? Okay, we're going to refer to this as what we call growth. And that something is growing exponentially. If you think about a petri dish full of germs, we've always learned that if you leave something out too long, germs, bacteria seems to multiply. And it doesn't multiply just by 1, it multiplies by double sometimes triple. And the growth of those bacteria goes up exponentially. Okay, so it's almost like it starts kind of sort of constant and then all of a sudden, whoop, it goes up. Okay, same thing on the flip side here. You start with something at a pretty high amount, and next thing you know, as time goes on, actually time doesn't have to go by, it doesn't take much time, it goes whoop, down like this. And on the flip side, we don't call it growth. When you read from left to right and it looks like it's going downwards, we refer to this as what we call decay. And that something is going down. Okay? Now, before we actually get into the whole graphing aspect of this, we still need to talk about this equation. Okay, remember, we've already defined the equation in that, remember, A can't be 0, B has got to be greater than 0, and B cannot equal 1. Okay, remember, those three are a requirement. Okay? So in the equation y equals a times b to the x, a is going to refer to our y-intercept. Very important. You need to understand. Remember, y-intercept is where we start to graph. So this is always the y-intercept. Always, always, always. Okay? And the letter b determines if we will have growth or decay. Okay, and we're going to talk about that in a few moments. So again, what are these pieces here? A is the y-intercept. So, if I ask you to plot something, that's a really easy given point that you can do right off the bat. It's just, plot that one point. Okay? Then the B here is going to determine whether or not we have growth or decay. Okay? So we're going to talk about that right now. Okay, so now how do we determine whether or not, just by the looks of the equation, if we're going to have something that goes up or if it goes down, meaning do we have growth or decay? Well, remember, it's all dependent on that B value. So the deal is, if B is greater than 0, okay, meaning that it's positive, we will have growth. Okay, and again, growth refers to this type of J-curve. Okay? Now, the way that you interpret this inequality here, this is referring to if B is between 0 and 1. Okay? For example, a half, a quarter, 1/3. Okay? As long as B is in between 0 and 1, then you're going to have decay. And remember, that's going to go down. Okay? So, you should be able to know at least two things as far as the graph goes. You should be able to determine what the y-intercept is, and you should be able to determine whether or not your equation is going to represent a growth or a decay. Okay? Now, we're going to look at this example right here, y equals 2 to the x. Okay? So far, all the rules are applied. Okay? Except here, I don't see a number, because it's y equals a times b to the x. Okay, I see this part, I see this part. I don't see an a, though. So what number can I put here? What a value can I place here that would not change the equation? Okay, and the answer is 1. So if I really wanted to, I can rewrite this as y equals 1 times 2 to the x, just to illustrate to you that we do have the a and we do have the b. Okay? Now, hopefully you guys have one of these. If not, there's actually many sites online that you can find. But by this I'm referring to is a graphing calculator. Okay, we really haven't used this yet, and we're actually going to use this as an aid to help us graph. Okay, so if you have one of these, great. If not, just follow along with me, and you can easily get caught up on this material through an online site. Okay, and we'll list some of those for you online. Okay, so first one we're going to graph is y equals 2 to the x. Okay, so y equals 2 raised to the x. All right, so I'm just going to set up my axis here for a moment. We'll just put it here. This will be my x-axis. Sorry, y-axis. And this will be my x-axis.